During a Math Olympiad training session in Germany, students were given a simple looking math equation. Many of them tried guessing the value of x, but nothing worked. The teacher smiled and said, "This is where logarithm saves the day." Let's see how. We know the property of logarithm that brings our exponent down. That is, log of a raised to the power m is same as m log a. And this is the property that solves this equation. Although we are also going to see second method, that is graphical and numerical reasoning to solve this question. But let's first solve using logarithm. So our equation is 4 raised to the power x minus 2 is equal to 40. Let's take log on both sides. So log of 4 raised to the power x minus 2 is equal to log of 40. Now our exponents comes here. So it becomes x minus 2 log of 4 is equal to log of 40 can be written as 4 cross 10. Now this x minus 2 log 4 is equal to, we know the property of logarithm, that is log of a cross b is same as log of a plus log of b. So we are going to separate this 4 cross 10. It become log of 4 plus log of 10. Now the question arises, why we have come to conclusion that we need to separate this? Because we want to divide both side by log 4. So here you will see this log 4 over log 4 cancel out, and this can be rewritten as x minus 2 is equal to log 4 over log 4 and plus log 10 over log 4. Now this is the reason we have separated this log 40 into log 4 plus log 10, because log 4 over log 4 cancel out, and we know the value of log 10 is 1. So we get x minus 2 is equal to 1 plus 1 over log of 4 can be written as 2 raised to the power 2. Now this 2 will be, this 2 as exponent will come here. So it become x minus 2 is equal to 1 plus 1 over 2 log 2. We use the property that log of a raised to the power m is equal to m log a. Now we know the value of log 2, which is log 2 is equal to 0.30103. So now our equation become x minus 2 is equal to 1 plus 1 over 2 times 0.30103. Actually, if you don't want to get into numerical, then our answer will be x minus 2 is equal to log 4 over log 4 cancel out 1 plus, we are not going to cancel out this log 10, assume the value of log 10 as 1. Just we are going to use the property that says log of a over log of b is equal to log a to base b. So this makes our equation as 1 plus log of 10 base 2, or adding 2 on the both side, x is equal to 3 plus log 10 base 2. But we are also going to find out the numerical answer, so that's why we are going here through these steps. So now x minus 2 is equal to 1 plus 1 over 2 times 0.3010. Now x minus 2 is equal to 1 plus, when you will solve this, you are going to get 1.66 something. So this become x minus 2 is equal to 2.66. Now adding 2 on both sides, we get x is equal to 4.66. So our value of x is 4.66, or if the options are not in numerical, then our value of x is going to be here, that is 3 plus log 10 base 2, that is 3 plus log 10, actually base 4 not 2, because here our was log 10 over log 4, not log 10 over log 2. So this is the equation, our answer through logarithmic method. Now what if we want to just get close to our numerical answer? So we can use the method of that is called graphical method or numerical reasoning. By using this graphical method or numerical reasoning, we can reach to a very close to our this value. So we are solving 4 raised to the power x minus 2 is equal to 40. Graphically, this means find the x coordinate where the curve y is equal to 4 raised to the power x minus 2 intersects the horizontal line y is equal to 40. So let's define our two function. F of x is equal to 4 raised to the power x minus 2 and g of x is equal to 40. And we want all x such that f of x is equal to g of x. Graphically, intersection point of the curve y is equal to 4 raised to the power x minus 2 and the line y is equal to 40. Now we know that our graph of y is equal to 40 will be horizontal line, as we have just said. So let this be the point of 40. So our y is equal to 40 graph will be like this. Now our second equation is y is equal to 4 raised to the power x minus 2. So when x is equal to 2, we get y is equal to 2 minus 2, which is 0, 4 times 4 power 0, which is equals to 1. So this gives our point 2 comma 1. So our second graph is starting from here, and this is going to be the exponentially type increasing graph, or we can say a strictly increasing graph. So now when x is equal to 4, we get y is equal to 16, and when x is equal to 5, we get y is equal to 64, that is 4 raised to the power 3 minus 2, 4 raised to the power 5 minus 2, which is 4 power 3, which is equal to 64, and here 4 power 2 is equal to 16. So our value of x is in between 4 and 5, in between 4 and 5. So when value of x is 4, our value is below the this horizontal line, and when value of x become 5, it is above the our line y is equal to 40x. So now let's try the value of x is equal to let it be 4.5. We are trying in between value of 4 and 5 so that we can get closer. So when x is equal to 4.5, we get y is equal to 4 raised to the power 4.5 minus 2, which is y is equal to 4 power 2.5. Now this power 2.5 can be solved as y is equal to 4 raised to the power 2 times 4 raised to the power 0.5. Now 4 raised to the power 2 is 16 times 4 raised to the power 2.5 will be 4 raised to the power 1 by 2, which is root of 4, which will be 2. So 16 cross 2 is equal to 13. So still our when x is equal to 4.5, our value of y is 32, which is still lower than 40. So now we have come to next step, that says our value is in between x is equal to 4.5 and x is equal to 5. So now let's assume another value. Let it be 4.7. So when we solve x is equal to 4.7, we get the value of y is equal to 42.2 something approximately. So now we have come to conclusion that our value is in between 4.5 and 4.7. And if options are given, then in Olympiad, now we can figure out our answer. And our actual answer was 4.66 something, and which is between 4.5 and 4.7. It means we are correct, and we are very close to our answer using graphical and numerical reasoning. Now there's also third method to solve this question, which is Newton-Raphson method. This method is very advanced and uses calculus. So in upcoming videos, we might, when we study calculus, then we might solve this same question using this Newton-Raphson method. So hope you like this solution, and thanks for watching.